Okay, so we're starting with number 5. 5 is a center of mass problem. So my y for this is just a diagram. Nothing else needed, no words needed, right? Just like in the example problems. So they tell us that we're going to have two situations. One, when we want to find the center of mass of the Earth-Moon system, and one when we want to do Earth, Moon, and Sun system. And so I'm going to need two diagrams for this, because I could do it all in one, but I think it'd be more confusing than doing it in two. They also tell me, at least for the Earth, Moon one, to use the Earth as my reference point. That's what they mean when they say x equals 0. That they say, use the Earth as your reference. So, I'm going to draw my diagram. Yours may not be as pretty as mine, but years of practice. We'll call that the moon. Earth, moon. And we'll do a second one over here where we've got the moon, Earth, and the sun. Objects are not drawn to scale. Yay. All right, so let's see. Remember on my rubric here for a diagram, I need to show the situation correctly, which I just did. All diagrams and locations required shown, all masses or forces shown, and correct labels on diagram easy to understand. So I need to add some masses in here, I need to add some locations, and things like that. So they told me to use Earth as my reference point. So I'm going to put a dot here and label that dot A. Just because I've read ahead, I know in the Sun-Earth one, they're going to tell me to use the sun as my reference point, so I'm going to label that with a dot and A. Right? But that's just because I've looked ahead. Let's see. Distance from the Earth to the moon would be the radius between the Earth and the moon. And that would be true down here also. And the distance from the center of the sun to the center of the Earth would be the radius of Earth, Sun. I think they refer to that as the orbital radius, so you won't confuse it with the planet radius. And then let's see, we should put in mass of the moon would be here, mass of the Earth would be here. Mass of the sun would be here. Now, there's only one thing I haven't put on my diagram, and that's where I think the center of mass in each of these situations is. Anyone want to suggest where the center of mass between the Earth and the moon might be? Besides between them? No risk takers? I like that. I would agree with that. So I'm going to say here, just to give myself a little space. And so that's the center of mass. And of course, from A to that point is xcm, right? Where do we think between the moon, Earth, and sun? Guys, remember, you don't, thank you, you're so polite, you ain't raising your hand. You don't have to, just yell out if you want.
2/3 of the way the sun and the Earth, closer to the Earth.
So like here?
Yeah.
Okay. And then, of course, that distance is, for this one, xcm, right? I think we got everything we need. Right, we got all the locations. How about, are they clear to understand the labels? And we got all our masses in there? Are there any questions on this complete Y before we move to the house? Did I put any equations in my y? No, never. I even avoided numbers just so I wouldn't take the chance of putting in equations. Right?
I use the reference point, right?
Correct. Yep. Why it's called A, I couldn't tell you off the top of my head. I knew at one point. Ready to move to the how? Okay. Do the how. So in the how, let's see, let's start with part A. I could copy things, let's see, I should look at my equation sheet. So I'm doing center of mass. Oh look, there's only one equation in center of mass, right? Yeah. Okay, so I think I'll use that one. So it says XCM equals, well, how many objects in the Earth-Moon system? 2. So I'm going to have 2 terms. M1, X1 plus M2, X2 over M1 plus M2. That's why that equation is set up as an unended series, right? Because you can have as many objects as you need, or that are in the system. So let's see. I don't know XCM, but that's actually what I want to know. Should we call the Earth or the Moon object 1? Okay, we'll call the Moon object 1. So its mass would be whatever the mass of the Moon is. Its distance from point A, we said that was the radius of Earth, Moon, plus object 2, which is the Earth, because process of elimination. It is 0 from our reference point. And then mass of the Moon plus mass of the Earth. And I know all those values. I'm waiting. What's up?
Wait, why is the mass of the Earth 0?
It's not.
I mean,
But the location of the center of mass from the center of mass of the Earth from the center of the Earth is 0. Remember back in our diagram, what did we pick for our reference point?
Oh, Earth.
Earth. So how far is the center of mass from the center of mass of the Earth? 0. Yeah, but that's why I think the diagram is so helpful.
How did you know the moon was 1 radius of the Earth away?
Okay. Good question. So the definition of how far is the moon from the sun is that it's 1 radius of the Earth to the moon. It's kind of a self-fulfilling thing. If I want to know how far away the moon is, it's the distance the moon is away. How far away the center of mass of the moon is from the Earth is how far the moon is from the Earth. That's how I know. And it tells me in the problem that what that distance is. So the Earth and the moon are this far apart. And we have to assume that they're meaning center to center. Because I don't think they say, let's see how they say it. The mass of the moon, the mass of the Earth, the mass of the sun, the distance between the moon and the Earth is this. Since they don't say like from the surface of the moon to the surface of the Earth, we're going to assume that they're talking about from the center of the Earth to the center of the moon. It's really such a small difference when you're talking about this scale of things that it doesn't matter. But we'll assume that they were trying to make life easier for us, not harder. Does that help?
Yeah.
Okay. So like on your equation sheet, I give that distance also. Right here. Radius Earth to Moon. And that's from center to center. Okay? So if you weren't given it, you have this little astronomical data chart here on the back of your equation sheet. If you're right. But all those would be center to center. And you guys can do that because you know the mass of the moon, you know that radius it gives you, you know the mass of the Earth. Just plug it in your calculator, right? Yes? Good. So, on to part B, which, because I'm the instructor, I have the hidden power of being able to show it before I answer part A. But I'm confident you guys will do well in that multiple choice. Part C says, let's consider this for the Earth, Moon, and Sun, and let's have them line up like that. And yes, I've seen this before, so I knew how to do my diagram, so they worked out. All right? And we're taking the Sun as our point of reference. So, part C. Now I could write my equation again, copy it, but I think I'll just write it filled in. How many objects do I have this time? 3. Moon, Earth, and Sun. Right? What do you want to call object 1? The moon again? Okay. So, mass of the moon, and then how far the moon is from the sun. Well, the moon is from the sun, the radius of the Earth to the moon, and the radius of the Earth to the sun. Right? From point A, which is the center of the sun, to get to the moon, you've got to go both of those distances. So whatever that is, radius Earth to moon plus radius Earth to sun plus, let's call the Earth next. So mass of the Earth, and then it from the point of reference is Earth to sun plus mass of the sun. That looks horrible. Let me see if I can write that a little bit better. Plus mass of the sun times 0. Remember, because it's 0 away. And then you have the 3 of these. And again, it's all values you know to solve for the one you don't know. Right? So this is number 12. And we're asked, at what altitude above the Earth's surface is the gravitational field strength equal to, in my case, G over 4? Yours is what? Okay, so they're different. Good. So, it's about gravitational field strength, not gravitational force. So I'm going to start off right away. This is number 12, right? With the grav field is created by the mass of the object. This case, what is our object in this case? Right, Earth. No, but the thing that's creating the gravitational field is Earth. Right? What else affects how strong the gravitational field is besides how much stuff is in the Earth? Or the distance between the point and the center of the Earth, right? Because remember, there doesn't have to be anything else there, right? So, how far the point is from, and here's why I think you gain a lot of points by saying from the center of the Earth. Because that shows you really understand what's going on, and hopefully that'll help you avoid a problem. I think if you had those 2 points, that would be full credit because you've shown you understand the physics. It's a clear link to the problem because you've mentioned always referring to the Earth. And I haven't put any equations or anything about how I'm going to solve this. Just this is the way the universe works. And that's the key for the why, right? It's why does the universe work this way? Why? Now we go to how the universe works. And we need an equation because that's our first rubric point. So it's going to be somewhere in gravity. We got a lot that says forces in gravity. And this is probably one of the things that you have to just kind of remember is the variable for gravitational field strength is little g. And right here we have an equation that says little g equals, that could be helpful. And so I'm going to use that equation. Let's see. So I've got g planet equals big G, mass of the planet, over the radius of the planet squared. Now, that's actually, I'm going to take the P off of that one because that would only be P if I was standing on the surface.
You have to write out that.
Yes. Yep. For what? For today?
Yeah.
No, on the, wow, okay. Someone else asked this earlier. When we're doing homework problems, which these are, I check the Y's at the beginning of the class for attention, and then the grade on the hows come from the site, and you finishing the problems on the site. Like the other 3 problem sets that we've done? Okay. I'm never going to physically check your Y's. If you want to come, your hows, if you want to come by with them, I'm more than happy to go over them with you. On the test, I'll check those hows using this rubric to assess your hows, and that's where the grade will come from on that. But for homework, it's automatically graded through the Pearson site. Okay? I should probably also get big G from my equation sheet, which is 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. Huh? Either one. Oops.
I have a question.
Yeah.
So, you know when yours had yours was like over 4 or whatever?
Uh-huh.
Is that what you plug in next? Like after the point? Is that what you plug in for M or no? Oh no, that's next.
Right. So that's what I was going to go to. At what altitude above the Earth's surface is the gravitational field strength equal, for me, G over 4? So I've got my Earth here, right? At some point here where this is G over 4, and I'm asked the altitude here, right, which is from that point to the surface. But what I'm measuring here, what this R is that distance. Maybe I should do that distance in red. Is that the same as the altitude? How's it different?
The other one's from the center, the other one's from the surface.
And, okay, so this is the radius of the planet. This is the radius of Earth, right? That little bit in here. So that plus the altitude gives me what this R is. Is that, remember the R is how far I am from the center of the Earth.
So, we're just trying to find the altitude, right?
Yeah.
So then how does the 2 over 4 help us? Or the 2 over, minus 2 over 7?
Yep. Well, in problems, typically when they just refer to little g here, they're referring to the gravitational field strength at the surface of the Earth. It's a common thing to use that for that. And on our equation sheet, we have that value. It's right here, 9.81 newtons per kilogram. Oh, should we go? Okay. All right, so 9.81 newtons per kilogram. So they're saying 1/4 of that value.
Or 1/7.
Or 1/7 or whatever it is. Okay. So, it came out in Unit 2 twice because I made a slight revision. So I think it's like third or fourth from the bottom of the unit. So let's see, we'll color that one. So I know my gravity I'm looking for. For me, that's 9.81 newtons per kilogram over 4 equals big G, 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. Mass of the planet. I'm going back to my equation sheet. Mass of the Earth, 5.98 times 10 to the 24th kilograms. Man, that's a good equation sheet. Huh?
He was looking where you got the 9.81 from, but it's not that.
From the equation sheet also.
Wait, can you go back? Yeah,
What is the
Gravitational field strength.
Oh, okay.
And so if you just see little g, they're usually referring to the gravitational field strength on the surface of the Earth, which is 9.81 newtons per kilogram.
Oh,
Because we're so Earth-centric,
so, and it's over 4 because
because it said yeah, find when it's over 4.
what is the over 4?
And on the question,
1/4.
because on the
Like, if there was a diagram of the Earth, would that be like 1/4 of Earth's radius above the surface? Or?
No, that's what I'm trying to figure out.
Oh,
But I doubt it'll be a quarter because notice r is squared on the bottom there. Remember, because gravity is an inverse square law, so it falls off really quickly. Mass of the planet, what did I say that was? 5.98 times 10 to the 24th? 5.98 times 10 to the 24th kilograms. That is the mass of the whatever planet I'm talking about, which in this case happens to be Earth. It is. Look, here's our equation sheet. There it is. Man, that's a helpful equation sheet. And then the radius, that r is how far this point is from the center of the Earth. And I'm going to represent that by the radius of the Earth. Actually, I'm going to put in the numbers since I put in numbers for everything else. Remember, that's going to be the radius of the Earth over here plus the altitude. I can go back to my equation sheet and get the radius of the Earth. 6.38 times 10 to the 6th meters. 6.38 times 10 to the 6th meters plus whatever my altitude is. And don't forget that that whole term is squared. That will be the most common mistake, is just to drop that squared. Okay, so be careful of that mathematically. And then you can solve for altitude. 12. You know, a little cross multiplication, a little square rooting, a little subtracting, and you'll be all set. No, it asked me for the altitude.
I was just saying no.
Okay. Olivia, it asks me, it says, what height above the surface of the Earth? The common word for that is altitude. You seem to be in the middle of a question, Ms. Cadell. You seem to be in the middle of a question. Please stop. Aww. Turn this back up. This equation reads, the gravitational field strength at some point is the universal gravitational constant, say G, times the mass of whatever is creating it, in this case the planet, and over how far that point is from the center of the planet. And they said, how high above the surface of the planet would you be if the gravitational field strength was 1/4 of what it is on the surface of the Earth? That was what the question was. So the gravitational field strength at this point is the gravitational field strength at the surface of the Earth, 9.81 newtons per kilogram, divided by 4. That's what it is at this point out here in space. The 6.67 times 10 to the negative 11? Here? Well, the red line on the notes here is how far that point is from the center of the Earth. That, we broke that up into two parts. The altitude, how far it is from that point to the surface of the Earth, because that's what they asked for. And then to get the rest of the way, we'd have to go one radius of the Earth. And so that number is the radius of the Earth from our equation sheet. Yeah, I thought that might be a little confusing the way. All right, I will